Let's look at this numerical, which actually contains the computation of the death strain at risk as well as the mortality profit computation for three different sets of policies. One, a term assurance policy, one, a set of endowment assurance policies, as well as temporary immediate annuities. So all these are being packaged into one single kind of a numerical. And just to reiterate the concept, whenever we talk about the death strain at risk, how do I talk about it? For any particular policy year, right, for a year, let's say T plus 1, if I want to find out the death strain at risk, it is nothing but whatever is the sum assured minus whatever are the reserves as of T plus 1 years, which means that is the excess strain. Sorry, whatever the company has set as the or whatever the company has planned as the reserves at the end of T plus 1, and I'm looking at whatever is the death benefit that has to be paid. So the excess is what we are calling as the death strain for the year T plus 1. And this entire death strain, this is for one single policy. If I multiply this by Q, this is what I'm going to get as the expected death strain. And on the other side, for when I am looking at from an actual death strain perspective, yes, for every policy, this is the actual death strain. Now, depending on the number of deaths that have occurred, I will sum up with the number of deaths, which will give me the actual death strain, right? This number multiplied by the actual number of deaths is going to give me the actual death strain. So expected death strain minus the actual death strain is what is going to give me the mortality profit. So for every kind of a policy, the mechanism that we are using for computation remains the same. So under that assumption, let's go ahead in terms of looking at or documenting some of the stuff. A life insurance company issues the following policies, okay? There is the first set of policies, which is a term assurance policy, which is for a 15-year period. There is a term assurance policy for 15-year period, sum assured of 150,000 that is paid at the end of the year of death. Okay, this is one policy. Then we are talking of 15-year pure endowment. This is not endowment assurance, it's only pure endowment, which would be paid, right? It is a pure endowment policy, it's not an assurance based policy, right? Let me call it as pure endowment. So pure endowment, let's say 15-year maturity policy, sum assured of 75,000. If the person, if the life stays up to the end of 15 years. And then we are also calling as temporary immediate annuity, which is for a 5-year period, and it's a single premium policy. Okay, premium is regular annual premium here. Here it's regular annual premium, and here it's a single premium policy. Okay. Annual benefit is payable in arrear of 25,000. So every year there is a benefit of 25,000 that is paid in arrear. So these are the three policies. And okay, on January 1st, 2002, the company has sold 5,000. So here we could talk about this as the benefit amount, right? This is the duration of the policy, and the premium mode, which is regular annual premium here, the number of policies sold. The number of policies sold, we are talking of 5,000 term assurance policies, 2000 endowment policies, right, and 1000 temporary annuity policies. And here the customers are 45-year people, whereas for this it's 55-year. The gender of the customers is males, and even this is also male lives. For term assurance and pure endowment, premiums are payable annually in advance, whereas for the this one it's a single. During the first 2 years, there were actually 15 deaths from the term assurance policies written. So the actual deaths here, there were 15 here, but 5 from these two in the first 2 years. Right, this is issued in January 1st, 2002. So during whole of 2002 as well as whole of 2003. Calculate the death strain at risk for each type of policy during 2004. Right, so this is what I really have to compute for 2004, and a few basic assumptions that I can make is the interest rate, right, apart from this group wise, I can even make a few basic assumptions. The interest rate is 4%, and I'm also making that it is AM92 ultimate table, right. I'm making it as AM92 ultimate, whereas for annuity is PMA 92C20. PMA 92C20 is the table that I'm following for this. Fair enough. Now let's get started into the calculation one by one. Let's get started with the pure, let's get started with the term assurance policies, right? So let's get started with the term assurance policies. We will try finding out what is the annual premium. Okay, how do I write it? The annual premium P A double dot, and this is 45:15, right? This is the premium. This should be equivalent to 150,000 is the death benefit, and it is paid on the death of this A4515. The expected present value of this is going to be this one. So alright, so I need A double dot 4515 for that. A double dot 45:15 is something which I require. A double dot 45:15 is what I require, and at the same time A 45 capital A 45:15 for a term life is also what I require. Right, these two at 4% interest. We can directly look out for these two numbers. We can directly look out for these two numbers under the table of n minus x, 60 minus x kind of a mechanism, right? Because this is 45:15, I can look out for A double dot xn, right? A double dot xn, I'm getting it directly as 11.386. I'll get my value directly, 11.386. And yeah, A 45:15, that too for a term life, I may have to find it out as A 45. Okay, I'll have to find out A 45, then 15P45, 15P45, and along with that V power 15. So V power 15 is 1 by 1.04 to the power 15, which we got it. 15P45, I'll compute it as L60 by L45. L60 for me is operating out as 9287.5 2164 divided by L45 9801.3123. So this is 15p45 and A45 at the rate of 4% interest. I will get my A45 from the tables as 0.27605. 0.27605, which is giving me A4515, which is A40, and I also require A60 as well for doing this. So I also require A60, which I'll get as 0.4564. So using these I can find out A4515, which comes out as A45 minus 15p45 times V per 15 times A60. So coming out as 0.03, and this entire number, right, this entire number I can multiply by the sum assured. So I'll call as expected present value of the death benefit here. I'll get this multiplied by 150,000. So this is what comes out as the expected present value of the death benefit. So from here I can try computing the annual premium for the same, which is expected present value of the death benefit divided by A double dot 4550. So 473.2093 forms the annual premium in case of term assurance. The same logic now I can go with respect to, with respect to the pure endowment. In case of pure endowment, we know the premium computation is comfortably simple. The way we compute the premium, right, the premium times again A double dot 4515, because this is also the same 15-year policy, but the only difference being 75,000 is paid only on survival, which is V power 15 15p40. That's it. 45 15p45. So this is what I can compute as the premium. So expected present value of the benefit here, directly I can use the numbers which we have found out here. I require V power 15, which we have found out. I require 15p45, which we have found out. So from there I can find the expected present value of the benefits directly. So V power 15 is coming out here. The 15p45 is coming out here. The expected present value of the benefit comes out as 75,000 times this number multiplied by this, which is working out to 39,460. So from here I can find out the annual premium quite comfortably. 39,460 divided by 11.86, which brings me 3,465. So this is the premium that is being computed in this case. And okay, so these are the premiums that we are accumulating in each of the years, and based on this premiums I could very well compute, based on this much of premium that so I can very well compute the provisions as the requirement is for 2004. So I'll talk about provisions at end of third year. For each of them I can find out the provision at the end of the third year, which means it is nothing but the expected present value of the death benefit minus the expected present value of the premiums. So what is the expected present value of the death benefit here? 75,000 times A4812. After 3 years, the expected present value of the death benefit is A4812 minus the expected present value of the premiums is going to be whatever premium 47.473.2093 multiplied by A4812. So for this I require capital A4812 as well as small a double dot 4812. So again I can follow the similar kind of logic here. Right, let me take similar kind of logic to proceed. But the only thing is I don't require A4515 now, I require A4812. Even that A4812 I can get directly from 60 minus X table for 4% rate. I'll get from the 60 minus X table n minus 60 minus X for 4812. 4812 A double dot is giving me 9.613. All right. Similarly, I am more interested in finding out A for capital A4812 in case of term life. So for that I require A48 separately. I also require 12P48 and I require V power 12. So these numbers are required, A60 also. And let's say in this case A60 is already known, because I can directly take the A60 as this number direct, and A48, yes, I'll get my A48 as 0.30695, which is A48. 12P48 comes as L60 by L48. L60 is 9287.2164 divided by L48, 9753.4714. So this is 12P48. Then this becomes 1 by 1.04 to the power of 12, which gives me this much. So from here I can find out my A4812, which works out as A48 minus the multiplication V12P48 into V power 12 into A60. So this is coming out to this much. So from here I can find out the expected, so probably the reserves, the prospective reserves at the end of the third year is nothing but the expected present value of the benefit, which is this number times whatever is the death benefit, which we talked about, 150,000, minus I am also looking at the premium, which is 473 times the expected present value of the same. So 777 came out as the reserves for that, for the term life policy. Similarly, I can talk about the prospective reserves for this also. The expected present value of the benefit is going to be 75,000 A4812 only on survival, right? So which is nothing but 75,000 times 12P48 times V power 12. This is the expected present value of the benefit minus the premium whatever is being paid, A double dot 4812. We have already computed A double dot 4812. So in this case I can directly compute it. The first thing is whatever is the death, whatever is the benefit times 12P48 times 40V power 12. So this is the expected present value of the benefit. minus I want to find the expected present value of the premium. The premium is 3465 into expected present value per those is this much. Filing out that the reserve that has been built up, the reserve requirement at the end of the year 3 is 11,289 in case of the pure endowment policy, whereas it is around 777 in case of the term life policy. Now we could also talk about the reserve that is required in case of temporary initial immediate annuity, which is nothing but for the next 2 years, because it's an immediate annuity for the next 2 years, as long as the person is alive, 25,000 has to be paid. So that much should be the part of the reserve. So which means in that case my reserve requirement should have been very straightforward. 25,000 times A double dot 58 colon 2. That is my reserve requirement. It's as good as we can, sorry, this is at the end of the period. So at the beginning of the period, if I have to try to bring out, I'll write it as A double dot 58 colon 3 minus 1. So I can directly get A double dot 58 colon 3. So I'll find out for a temporary immediate annuity, I'll find A double dot 58, right? I'll find A double dot 58, V per 3, 3P 58. So from based on this, I also require A 61. Right, all these things will help me in terms of arriving at A double dot 58 colon 3. So for this, yes, I'll get A double dot 58. If I require A double dot 58, it is 14.847. Okay, V cube is 1 by 1.04 to the power 3. 3P58 comes out as L61 by L58. L61 is 9212.7143 divided by L58, 9413.8004. So this is 3P58. Then we have A61, which is straightforward. A double dot 61, right? This is A double dot 61. I have A double dot 61, which is straightforward value, which is coming out to 13.769. So from this I'll get A 58 minus V per 3 multiplied by 3P58 multiplied by A double dot 61, resulting in this of around 2.86. So this I'll take minus 1. So probably what I'm getting is the reserve requirement here is coming out as 25,000, whatever is the benefit amount that needs to be paid, multiplied by this number minus 1. So the reserve requirement is almost 46,696. A double dot 58. A double dot 58 right? So this is what is working out to sum 46,696. Now this is where I'm going ahead in terms of finding out the sum that is at risk, right, which is nothing but the DSAR for each of them. Debt sum that is at risk. Death strain which is at risk. How much? Here, in case there is a death benefit that needs to be paid, it is 150,000. But the reserve is only for 777. So, in case the death happens, the death strain that is at risk is this much. Whereas in this case, the benefit that has to be paid is 70. No, this is in case of death, there is nothing, only on maturity, which means the death strain that is at risk is minus 11,289, because if death happens, nothing needs to be paid. The same logic here, whatever is required, 37 minus 46,000, whatever is the case, and whatever is the amount that is at risk, 25,000 that is being received, what that 25,000 that needs to be paid as at the end of the year, even that would be saved. So overall there is a death strain at risk of this negative number. Now on this I can compute the mortality profit by finding out the expected death strain at risk. So for each of the cases I'll try to find out the expected death strain at risk, right? So for this particular year, if I have seen, there are already 15 lives that are dead. So the lives that are there at the end of this particular year are only 5,000 minus 15. Out of these lives, right, out of these lives, I am looking at the Q47. Because by this time we are talking about these are issued for a 45-year-old person, 2 years are already gone. So I am looking at Q47. What is the probability that a 47-year-old person is going to die? Which is working out to 0.001802 from the table. So this is the probability that a person is going to die. And in case he is going to die, the death strain is going to be this much. So the expected death strain here is working out to 1.34 million. Right? We are talking about a death strain of 1.34 million. And here, okay, this is the death strain. And what is the probability of death? In this case, the probability of death again is dependent on Q47 itself, which is 0.001802, and the number of lives who are still alive or number of policies that are still alive during this period is only this much, resulting in a death strain at risk of minus 40,000 in this case, the expected death strain. Similarly here, the death strain, in case the death occurs, this is the strain. The probability that the death occurs here is Q57, because these are issued for 55-year-old people. Q57 is 0.005650. This number multiplied by how many policies are there still? 1000 minus 5. 995 policies are still there. So the expected death strain in this case, right, the expected death strain in this case this has to be this Q has to be looked at from a different table. I can't look at from AM92. I'll look at it as PMA92C20 table. Yeah, this is where I have to be slightly careful about. I will look at PMA92 table, not this. So the QX for 57-year-old person, I will take it as 0.003759. Right here I will take it as 0.003759. So if I look at it, it is okay. For a 57 PMA 92, okay, PMA 92 C20, I think I have taken it wrongly. For a 57 it is 0.001558. It is 1558, making that the expected death strain in these cases is going to be these numbers. Now I'll find out the actual death strain, which I'm taking. During 2004 there were 8 actual deaths, so here I'll also put the actual deaths now, right? These are until the previous year. So the actual deaths, there were 8 during this year from term assurance, 1 actual death from each of the other 2 kinds of policies. So this is where if I look at the actual death strain, okay, this number for each policy, there are 8 such deaths that have occurred. So which means this is the actual death strain. Whereas this is for each policy in case the death occurs and there was only 1 death. So this is the actual death strain. Here also the death strain is this much. The death strain is going to be, for each policy the death strain is going to be this number. I multiply it with the number of deaths. Here also the death strain for policy is going to be this number, multiply with the number of deaths. So these are the actual death strains. So from here I can find out the mortality profit, which is the expected death strain minus the actual death strain for each. So here there is a profit, whereas here there is a loss, and here also there is a loss. So overall mortality profit for me is nothing but it's a summation of the profits that are coming from these 3, resulting in almost a $77,936 of profit. So probably here also when I think A double dot 58, I think I have taken this from, right, these numbers also I have taken them from AM 92. Rather I have to look at PMA 92 C20 table. So let me just adjust them a little bit, right, because a few calculations will change based on the PMA 92 C20 table. A double dot 58, A double dot 58 is going to be 16.356. V per 3 is fine. 3P58 also, it goes as L61, L61 by L58, even that I have to take as per this table. So L61 for me goes as 9802.048 divided by L58, 9864.803. So 3P58 changes a little bit, and A double dot 61 also changes, which becomes 15.254. So because of this, the numbers change a little bit across, resulting in an overall mortality profit of 77,748. So, I mean, at least the understanding of the concept, especially of death strain at risk, computing the expected death strain at risk, actual death strain at risk, and from there moving further in terms of computing the mortality profit for each of the policies, and then getting into the combined mortality profit computation as well. All right.